Hello, and welcome to the Build at Scale Lab. In this assignment, you will be responsible for programming and integrating an autonomous process. This will be the first video in a series of videos where we will teach you everything you need to know to accomplish this lab. But in this video, we're going to start off by showing you all the robots and tools that we're going to use, and then we'll go over the objectives of this lab. The first robot we'll introduce is this Techman TM12. It's a 6-axis cobot arm with an integrated vision system. So it's got a camera on it that you can do all sorts of computer vision related tasks with, such as object detection, defect detection, barcode scanning, and more. The TM12 is programmed in a software called TM It's an incredibly intuitive flowchart-like software that allows you to program motions for the robot. The second robot that we'll be using in this lab is this FetchRobotics Freight 100. It's an autonomous mobile robot, or AMR for short, and this particular AMR has Fetch's Cart Connect module on the top.
The Cart Connect module works like this. The AMR will navigate to the cart and then drive under it. Once it is in position, it'll raise the spikes, which locate on a plastic piece on the bottom of the cart. With the cart secured, the AMR can drive away. The Fetch AMRs are programmed through a software called FetchCore. FetchCore is where you can create your maps and set your points and your routes. It's where you can monitor your robots to see what their state is. It's where you can program workflows for them in this block-like programming language.
Both TM Flow and FetchCore are pretty intuitive pieces of software to use, and anyone can get started with them to program the basic motions for these robots. Honestly, with a lot of modern autonomous systems, the hard part isn't programming the individual robots, it's getting the robots to work well together. This is known as integration, and to help with this, we'll be introducing a tool called Node-RED.
Node-RED is an open source, flow-based, low-code programming tool that makes it much easier to program and communicate with a variety of systems. We will go into programming in Node-RED in much greater detail in videos later in this series, but I'll run through 2 examples super quickly. This flow here is designed to pull the joint positions off the Techman TM12 Cobot. So for each of the 6 joints on the robot, we will get the position of those joints in degrees. The TM12 supports a protocol called Modbus. So I've grabbed a Modbus read node from the palette here on the left. I've configured the Modbus read node with these parameters, knowing from the TM12's documentation that this address is where the joint positions are stored. And I'm going to pull for the joint positions every 50 milliseconds, which is pretty quick. Due to the way that Modbus works, the result out of this node won't be superhuman readable. So I've got a function node that basically just cleans up the output and then puts it in an array of doubles that represent the joint positions in degrees. And then lastly here, I've got this debug node. This is basically just a print statement that will print the results to the debug window. So I'll just wire up these nodes and I'll deploy it. Now you can see the joint positions streaming from the robot in the debug window. The second example will demonstrate the Node-RED dashboard nodes. These dashboard nodes are used for building super simple interfaces that will be hosted on a web page. All you need to do is drag one of these nodes. I'm going to use a button node, and I will configure it and say I want it on the home page, and I will just add a button label and call it my button. And when this button is clicked, I want it to send a message that says button clicked. Great. Okay, now what I will do is I will wire that to a debug node. So when that button is pressed, we should see it here in the debug window. Now if I deploy this, and I can find the web page that was created for me by going to my Node-RED instance, which for me right now is running locally. Put that into my browser, go /UI, put that in. Now this is the web page that was automatically generated for me with my button that says my button. And when I click this button, I go back to my debug window, you can see here it says button clicked. So if I go back here and click this a few more times, you can see a few more messages.
Now that you're familiar with the robots and tools involved, let's go over the lab objectives.
Your first objective will be programming the TM12 to pick up the cup from the table and place it on the fixture on the AMR. You will also have to program the TM12 to remove the cup from the AMR and put it back on the table. Next, you will need to program two workflows in FetchCore. The first one will drive the AMR over to the manual station. You'll have to ensure that the AMR is in the right orientation so that the cup is presented to the operator at the station. And then the other workflow that you'll have to program will drive the AMR back to the Cobot, again ensuring that the cart is in the proper orientation so that the TM12 can pick up the cup. For the integration, you will need to program 3 flows in Node-RED. The first flow should create a button, and when that button is clicked, it will load and start the pick and place program on the TM12 to pick up the cup and load it in the cart. This Node-RED flow will also have to monitor the state of the TM12 so it knows when the program is done, and so it should tell the AMR to go to the manual station. The second flow is much simpler. It is for the operator of a manual station. After they have taken an item and placed it in the cup, they can press a button, which will then tell the AMR to take the cart back to the Cobot for unloading. The third Node-RED flow should get kicked off by an event from FetchCore that says, hey, I'm done with my mission and the AMR has returned. Node-RED should handle that and tell the TM12 to start its unload program to take the cup off of the AMR and put it back on the table. So running it back from the start, the entire flow looks like this. You click a button, and the TM12 loads the cup onto the AMR. When the TM12 is done, it automatically tells the AMR to drive to the manual station. The operator puts an object in the cup and then hits a button. The AMR drives back to the TM12, where it's automatically unloaded. The other videos in this series will dive into the technical details of how to actually do all of this. During your assigned lab slot, you will have a limited amount of time to build all of this out, so to get it done in time, you should divide and conquer, so come prepared with a rough plan of who will do what. It is absolutely essential that you review the provided materials ahead of the lab. We're really excited to be offering this lab, and we're hoping it'll introduce you to some new tools and give you a more clear mental picture of how autonomous systems interact. Thank you for watching.